Today we solve a system of 3 equations using Gauss, Jordan elimination and reduced row echelon form. By the end of this video, we will reach the exact values of x, y and z step. The first step is to convert this system into an augmented matrix, and this is how we do it. Now we take the coefficients of each variable in this question and we close them. So we write one, the coefficient of 1, the coefficient of x, the coefficient of y, the coefficient of z in the first equation, and then the constant. Then we write down also the coefficient of x in the second equation, then the coefficient of y, then the coefficient of z, and then the constant -4. Then we write the coefficients of x, y and z in the last equation, which is -2, 3, 4 and then 40. This is called an augmented matrix. An augmented matrix. Now from here we need to use Gauss-Jordan method to convert this equation, this matrix, into a reduced row echelon form. A reduced row echelon form, which means that our new matrix should always look like this: 1 0 0 0 1 0 1 0 0 1, and then C1, constant 1, constant 2, constant 3. Our new matrix should always look like this, so that if we go take back, the first row represents the coefficient of the first equation, the second row represents the coefficient of the second equation, and the third row represents the coefficient of the third equation, such that we're going to have, like for example, one in the first row, 1x plus 0y plus 0z is equals to C1. So clearly x will be C1, the same applies to y will be C2, and z will be C3. That's our main plan or goal at the end of this video. So how do we come up with a reduced row echelon form? Let me wrap the board. In the first row we already have 1, so we don't need to look for 1 in the first row. We eliminate the x terms below it. We eliminate 3 and we eliminate -2, so that we get 0 0 in the first column. We already have 1 here. So how do you do it? What you're going to do is row 2 becomes row 2 minus 3 times row 1. So this is row 2, r sub 2, which stands for row 2, becomes row 2 minus 3 times row 1. So you shall have row 2 is 3, let's write in column form, -4, -1, then minus 3 of row 1 is 1, minus 3, -1, minus 3, 1. In that case, this will give us 3 minus 3, which is 0, and then we have -4. This will be plus, -3 times -1 will be plus. So -4 plus 3 will be -1, and then here we shall have -1 minus -3, which is -4. So what you're going to have is our row 2 will be 0, -1, -4. So let's wrap that. Our new row 2 will be then we forgot to add this because we need to add also -4. So that will be -4 minus 3 times -6. This will going to give us, this is positive 18, -4 plus 18 will be positive 14. So the whole of row 2 changes to 0, -1, -4 and positive 14. So we're going to eliminate the original row 2 and replace with 0, -1, -4. Now row 3 becomes row 3 plus 2 times row 1, 2 times row 1. So our row 3 is -2, 3, 4 and 14. We add 2 times row 1, which is 1, plus 2 times -1, plus 2 times 1, then plus 2 times -6, and this will give us 0. This is -2 plus 2. This is going to be 3 plus -2, that is 1. This is going to give us 4 plus 2, which is 6, and then you're going to have here 2. So our new row 3 will be, we're going to remove out the original row 3 and replace with our new row 3, which is 0, 1, 6 and then 2. So that's, you can see clearly that in the first column we have achieved our goal, which we are supposed to have. On the left side, you can see the row echelon format, the final row echelon format. In the first column, we shall have 1 0 0. So we already have that. Now we go to the second column and we make sure that we should have 0 in the first row, 1 in the second row, and 0 in the third row. Now, how do we achieve that? We multiply row 2 by negative 1. If you multiply row 2 by negative 1, you can have negative 1 times 0. That is 0. Negative 1 times negative 1 is positive 1. So that negative will disappear. And then negative 1 times 4, we shall have positive 4. And then negative 1 times 14 will have negative 14. So that's our new. Then from here, we are going to do some changes again. Row 1 will be row 1 plus row 2. Because our main interest is to get 0 in the first number of the second column and to get 1 in the second column, in the second row, second column, and then get 0 in the third row, second column. So first is we convert row 1 into row 1 plus row 2. So row 1 is 1, negative 1, 1, negative 6. We add row 2, which is 0, 1, 4, and then we have 6, 2. We have 2. Row 2 is 0, 1, 4, and negative 14. Our new row 1 will be 1, 0. Then we have 5. Then we have negative 20. So we're going to remove the original row 1 with these values. Replace with these values. So 1, 0, 5, and negative 20. How do we convert this number into 0 again? That's the number that need to be 0 to match the row echelon, the reduced row echelon form. So we shall convert row 3 by subtracting row 3 and row 2. Subtract row 2 from row 3. So our new row 3, okay, our old row 3 is 0, 1, 6, 2. Then we subtract row 3 to row 2. Row 2 is 0, 1, 4, and negative 14. We subtract this. If we subtract those, we get 0 minus 0 will be 0. 1 minus 1 will be 0. 6 minus 4 will be 2. And then 2 minus 14 will be 2 plus 14, which is 16. So we shall again remove row 2, replace with these values. Our new values are 0, 0, 2, and then 16. So our final step to convert final column 542 to 0, 0, 1. In the final column, not the constant column, but the coefficients of z in the original equation needs to be 0, 0, 1 in column 4, as you can see from the reduced row echelon form. So how do you do that? Again, we can come up with a logic to make sure that the first number 5 changes to 0, 4 changes to 0, and 2 changes to 1. The only way we can do that is we shall divide row 3 by 2. Row 3 by 2. So row 3 divided by 2 give us what? You divide row 3 by 2, everything here will be 0 divided by 0, 0, 0. But here is going to be 1 and here is going to be 8. So here we'll have 1 and here 8. 1 here and here 8. Then from there we can convert row 1 to row 1 minus 5 row 3. So row 1 is now 1, 0, 5, negative 20. Then subtract 5 row 1, row 3, 0, minus 5 times 0, minus 5 times 1, minus 5 times 8. So we shall have 1 minus 5 times 0 is 0. So 1 minus 0 will be 0. Here it's also 0. Here we shall have 5 times 1, which is 5. 5 minus 5 will be 0. Then here we shall have minus 20 minus 40, which is minus 60. So our new row 1 will be 0, 0, 3 zeros, and then minus 60. So we shall do some editing now. Here it's supposed to be, here it's supposed to be 1. Here it's supposed to be 1. 1 minus 0 will be 1 here. So we shall have 1, 0, 0, then negative 60. We have now changed the first number to 0. Then we expect the second row, the third number, to be also 0. So we can use the logic again by converting row 2 to row 3, row 2 minus 4 multiplied by row 3. That will be our new row 2. Our new row 2 will be, we take row 2 minus 4 times of row 3. So our new row 2 will be, first of all, our old row 2 now is 0, 1, 4, negative 14. Then we subtract 4 multiplied by row 3. Row 3 now here is 0 minus 4 multiplied by 0 minus 4 multiplied by 1. Then minus 4 multiplied by our row 3 now here is 8, right? Yes. So our new row 2 will be, 0 minus 4 times 0, which is 0. Then 1 minus 4 times 0, which is still 1 minus 0. That is 1. Then the last one, the third one is 4 minus 4. That is 4 times 1 is 4. So 4 minus 4 is 0. And then the final one is 4 times 8 is 32. So minus 14 minus 32 is minus 46. So this is our new row 2. So we eliminate the old row 2, and our new row 2 will be 0, 1, 0, negative 46. So like I showed you, C1 here in this case, our constant one will be negative 60, which means that is our x. Our x is negative 60. Our y is negative 46, and our z is positive 8. This is the full Gauss-Jordan form, start to finish. If this helped, like the video, subscribe for more clean step-by-step math, and share it with your friends who fear matrices.